For decades, it's been the standard story. Most of our universe is made of dark matter, this invisible stuff we can't see or touch. But what if the whole idea is wrong? Today, we're looking at a serious scientific challenger, an idea that questions everything we think we know. So let's just ask the big question right up front. What if dark matter is just a giant cosmic mistake? What if the problem isn't some mysterious, invisible particle, but our own understanding of gravity? You know, the very laws we've trusted for centuries. What if they're the thing that needs an update? And that challenger, well, it has a name, MOND. For a while, it looked like this incredibly elegant solution to one of the biggest puzzles in science. And the best part? No weird, exotic new particles needed. So what exactly is MOND? It stands for Modified Newtonian Dynamics, and the idea is actually pretty straightforward. Instead of inventing dark matter to explain why galaxies spin way too fast, MOND just says, hey, maybe gravity itself works differently, where its pull is super, super weak, like, say, at the very edges of a galaxy. Think of it like this. Here in our solar system, where gravity is strong, Newton's laws work perfectly. No arguments there. But MOND suggests that way out in the cosmic suburbs, the far-flung edges of galaxies where things are moving really slowly, the rules change. Gravity gets a little bit stronger than we'd expect. Okay, so it's a really neat idea, right? But in science, a beautiful idea isn't enough. It has to survive contact with reality. So how does MOND actually hold up when we put it to the test? Well, one of the best places to check is with something called wide binary stars. These are just pairs of stars orbiting each other, but at enormous distances. And because they're so far apart, the gravitational pull between them is incredibly weak. I mean, exactly the kind of place where MOND says we should see Newton's laws start to break down. So scientists measured these systems with unbelievable precision. And what did they find? A new law of gravity? Nope. They found absolutely nothing. No deviation at all. Even at these crazy low accelerations, gravity was behaving exactly the way Newton said it would. And you don't have to take my word for it. This quote from Indranil Banik, who used to be a big supporter of MOND, really says it all. When the data came in, the conclusion was just inescapable. MOND's big prediction in this crucial test just didn't match what we see in the real universe. And unfortunately for MOND, the problems just kept piling up. It completely fails when you try to use it to explain the movements of entire galaxy clusters. It can't explain why light bends around massive objects, something we call gravitational lensing. It even made a prediction that light and gravitational waves travel at different speeds, which we now know for a fact is wrong. One by one, the evidence was chipping away at the idea.
Now, all of those are serious problems. But for a lot of scientists, there are two key pieces of evidence that are seen as the real deal breakers. These observations don't just poke holes in the theory, they seem to blow it right out of the water.
First up is this, the bullet cluster. What you're looking at is basically a cosmic car crash. Two huge galaxy clusters slammed into each other. And what happened is amazing. All the normal stuff, the hot gas, shown here in pink, it all collided and got stuck in the middle. But most of the mass, shown in blue, just sailed right on through, completely separating from the gas. Okay, so here's the knockout punch. MOND is all about modifying gravity based on where the normal matter is. So it predicts that all the extra gravity should be centered on that pink stuff, the ordinary gas. But that's not what we see. The evidence clearly shows that the center of gravity, the bulk of the mass, is somewhere else entirely. This is a huge clue that the extra mass is a real, separate thing. Dark matter that can actually be separated from normal matter. And if the bullet cluster wasn't enough, another, completely different discovery came along that was just as damning. Astronomers started finding galaxies that seemed to have almost no dark matter at all. So why is that a problem? Well, in these galaxies, the stars move exactly the way Newton predicted they should. But wait a minute. If MOND were true, if gravity itself was different, that change should apply everywhere in the universe. The fact that some galaxies follow the old rules and others don't, well, that strongly suggests dark matter is actual stuff that can be in one galaxy but not in another. But all of these problems, they lead to what is maybe the most surprising and, frankly, kind of embarrassing issue for the whole theory. It's a really ironic twist in MOND's big mission to get rid of dark matter. So let's just ask the final, ultimate question here. Does MOND, a theory whose entire reason for existing is to get rid of dark matter, does it actually do it? And the answer is no, not even close. It's actually shocking. Even after you apply all of MOND's special rules for gravity, the theory still comes up short. To explain things like galaxy clusters, MOND still needs a huge amount of extra invisible mass, about a fifth of what the standard dark matter theory needs. So let me be absolutely clear about this. MOND doesn't eliminate dark matter. It just reduces the amount you need. The theory that set out to solve the missing mass problem still has a missing mass problem. And just so we're on the same page about how big this remaining problem is, that leftover missing mass, that 15%, that's not just some small rounding error. It is roughly equivalent to all of the ordinary matter in the entire universe. Every star, every planet, every galaxy. MOND still needs a whole other universe's worth of invisible stuff to make the math work. So what's the takeaway here? MOND was a beautiful, elegant idea. It really was a genuine scientific attempt to solve a huge puzzle by thinking outside the box. But as we've seen, reality has a vote, and observation after observation has challenged the theory pretty seriously. For now, it seems the mystery isn't in our laws of physics, but out there in the cosmos. The universe, it seems, remains stubbornly and fascinatingly dark.